and welcome to the video talk-throughs for From Social Science to Data Science by me, Bernie Hogan. This is Chapter 6, Accessing the World Wide Web. So the topics for this chapter, first we're going to want to start to understand how the web uses URLs and IP addresses to enable servers to serve data to clients. We'll end up being one of those clients, and we'll be asking for that data through URLs and I guess through IP addresses as well. We're going to want to make use of the request.get method. We're going to see that later on and see how we can do that particularly on Reddit, but also on a couple of other sites along the way. Within that, we're going to want to be mindful of a user agent, and we'll use the opportunity to for changing our user agent to also talk about the headers that you submit along with a URL when you're sending a GET request. We want to understand how paging can be useful with URL in order to build a data frame of content, and we're going to be showing that on Reddit, and so that's how we iterate through a number of requests. And we're going to want to consider data minimization as a key ethical issue in the use of online data, and we're going to want to be specific about that through considerations of volume, velocity, and variety. So first of all, what is the web? Lots of ways of describing it. Here's a one I've just made up. It's a decentralized assemblage of computers that facilitate the remote retrieval of data through a defined set of protocols. So those defined set of protocols, first of all, we can think of that as a network of networks. So these are computer networks, and each of them are connected through other networks. And it is decentralized, although it has a number of points of real centralization, such as DNS servers, that if those go down, it really takes down a lot of the web. But it's meant to be a robust and decentralized way in which computers can talk to each other to share data and find ways to transfer the data along those networks. Now, within that, as you can, I guess, probably have inferred already, data retrieval is requested by a client, and then it's fulfilled by a server. So a client will say, please give me this data in particular, or please open up some sort of port and start streaming data to me. So generally speaking, a client asks for data using a URI, which is a Uniform Resource Identifier. Now there's all kinds of those, like an ISBN is a URI for books in print. The World Wide Web has a special set of these sorts of identifiers. And those are with web addresses, and we refer to them as URLs, or Uniform Resource Locators. So now the web serves data. Sometimes we perceive this as documents or web pages. We might download a PDF or an MP3 file, listen to some music, but we might just browse the web through web pages. But often what comes down through the web, it's just data, and it's scripts behind the scenes. So normally you don't anymore. Well, you can, but you don't often browse a static web page, a page that's been kind of hand-coded and is there for you to look at. You see some of those from the early web days, and people can still do them. But for the most part, what you're more likely to see is data from platforms where there's a general look and feel or aesthetic to the platform, such as Twitter, which will have a news feed, or Facebook, similarly a news feed, LinkedIn. You get the idea. And as you scroll through that newsfeed, it's making lots of little calls, not for new web pages, but for new bits of data that it then renders as a web page as you scroll through the content. So back to in chapter 1 where we were talking about thinking beyond the interface. This is a way where we really have an opportunity here to go beyond that interface, think about that data, how we can request it, and thus shape it for our analysis. Now we request that data using the URL, and it can be from a browser, or it can be via code. We're going to see both of those later on, but of course I'm sure you'd be familiar with requesting data from a browser already. So what is a URL? A URL, or a Uniform Resource Locator, that has a number of distinct parts worth considering as separate. And I got a little schema here. The first bit we can see is a transfer protocol. HTTPS I've got here. Generally you want HTTPS protocols as opposed to HTTP. This is the S is for secure. We'll say a little bit more about that later. But then we have a domain name. Now this right here has a domain, which is reddit.com, and a subdomain, which is API. So here we have also a subdirectory path, and that there is the subreddit for Learn Python. It's actually a pretty neat resource. If you sort by top, you can often get really useful tips and sort of ideas for what to do for your Python. But anyway, here we're looking at it just as a URL. And you can see here a .json. Now, you wouldn't necessarily see that .json on a Reddit URL normally if you're browsing there, but you can actually put that on there, and it will return everything in JSON. Now, as it happens with this particular example, that's a bit redundant, because it'll also do that if you replace the www with API. But I wanted to have it in there so I could both show the subdomain and show the file type. Now, after the file type is the argument strings. So we have a question mark here that says it's the end of the URL, and tell me some parameters and how I should fill them up. And we have one here called after. We'll see that later on as well. So there's many protocols that you can see on the web, not just these like FTP and SFTP. You might not already know also about RTSP, or real-time streaming protocol. And there's a number of them, but mainly it's through HTTP or the hypertext transfer protocol. And so this domain name right here, it's resolved to an IP address. Really, what the networks are expecting are IP addresses, these numbers, and it uses those numbers to help route traffic through the web. So if you type in google.com, then it will a DNS server will take that google.com and return you. You need this IP address number right here. So speaking of which, here's some IP addresses. Now it might actually resolve to this IP address right here. This is where Google resolved for me earlier on today. I typed into a terminal. I went to just typed traceroute and then that google.com or www.google.com. So your computer can refer to itself as localhost. And you can have an address on your own network, and it might be something like 192.168.0 and then some number thereafter. Now, your computer network also has an address to the outside world, and that's typically what we refer to as canonically the IP address. Now, that IP address can change, but it can also be looked up. So, for example, you can use the MaxMind platform or a web page. The web page allows you to enter one IP address at a time in like a little box, but then you can also subscribe and get either a small number per month or pay for more lookups. I looked it up with my address this evening, and it got my postcode. So sometimes it doesn't work so well, but today it worked great actually. Now that being said, it did work great, and it's worth reminding that IP addresses are considered personal data in many jurisdictions, and they shouldn't be kept any more than a proper name. So if you're downloading a bunch of data from the web, or maybe collecting data from a survey, and that happens to have IP addresses in it, maybe for some security reason or whatever, you really shouldn't be sending those out if you make the survey like an anonymous or whatnot. The IP addresses are definitely not anonymous. So now the IP address itself goes to the network and to computers on the network, but the computer has a number of ports that it listens to and expects data on. So that's to help route traffic on your computer, so that everything is not trying to get in each other's way. So we have a variety of ports. 80 is for unsecured web traffic, so you might see :80 in a web page sometimes. Be very uncommon, but you can see it. And Jupyter Lab runs on 8888. So we've already seen that there, and you would see that on your own computer. It'll say localhost :8888. And indeed, over here it shows this up in my browser as well. If you happen to have 8889 or 90, that might mean that you have multiple instances of Jupyter running. Each are their own server, and so they use different ports to make sure that they're talking to the right place. And so now let's have a little look at the IP addresses. Let's go over to our web page right here once again. Remember at the beginning, restart and clear all outputs. And I've already got the table of contents open over there. So first I'm going to run through this. What's a URL? And let's see these IP addresses here. This is as far as we're going to get. IP address for Google. So I use this socket library. We don't commonly use that unless you're doing some kind of low-level networking stuff, but it's useful here so that we can see these IP addresses. My local IP right here. So we can see I'm 127.0.0.1. That is localhost. So actually, if you put this number right here, up here, then it would still work. My machine's IP address on my local network is this. This is now device number 117. We've got a lot of little gadgets around the house that are plugged into things. This really helps us remind about the Internet of Things. I don't know if there's actually 117, but that's what it is right now. And those can reset. They're not strictly that much of a security issue. On the other hand, your IP address is a security issue, like talking about on the slide there. And so instead of posting an IP address, I've done this little thing here where we take the IP, we split it. And so instead of having the actual numbers there, we just put little X's in instead. And yes, just a reminder there about the IP address and ethics. Okay, so now we have URLs. We want to work with them in some way. So we want to send data to the web or send requests to the web and get data back. So we should be able to use URLs. But you don't really want to type in the full URL all the time. So instead, you want to be able to parse that URL and make some changes to different parts of it. So let's have a look here at this one. So I mentioned this briefly earlier. The arguments, they go in the back. We have one here, the parameter, it's limit, and we put in the argument of 50. We're saying, can we get 50 rows or 50 entries, I guess, Reddit entries, whatever. Now it's worth noting that this right here is pretty straightforward, but there's times where you're going to want to put things in a URL, and they might have keys. So for example, I say, why are red M&Ms number 1? Now you'll notice that this quote here, it has a question mark, but question marks are reserved. It also has an and ands are reserved. Turns out the hash symbol is also reserved. I really just tried to do a number on this one. And if you type this into Firefox, let's watch. I'll actually do that here right now, and we'll see what shows up. So if we go over to why are red M&Ms number 1? Question mark. Okay, so now just watch what happens to the URL string. Okay, so what we got here, it shows the client. It's on Firefox. We can see that. And why are red M&Ms number 1? We've got all those escape codes right there, and so that way we don't have any spaces in the URL itself. Now this URL, we can see this URL with all the escapes and stuff by using the prepared requests method from request models. Now this model is a way of managing data. It's part of the requests architecture. You wouldn't normally use this unless you really want to see these requests like this way. Normally we just send requests the kind of this stuff right here, and it'll escape it for us. So now we can parse this as well using urllib.parse, so that all those things that I was talking about earlier, transfer protocols and domain name and so forth, that they can all be neatly segmented for us. So let's have a look at here. This is what it would the result would be in this case. Scheme, HTTPS right here. Net location, so that's the domain. Path equals /search, so that's this part right here. You know, that parsing can be really useful because then you can go and use it in order to alter parts of the URL. Have a look here at some web requests. So to interact with a server, there are a number of common requests. For fetching data, the two most common are GET and POST requests. A GET request is one where it contains a URL and a request header. And so you normally just say, hey, here's where I want to get the data from, and the request header might say, and here's some extra details that are going to help out in some way or another. Now, a POST request has those things, but it also has a payload. And that payload will be that'll be encrypted, or if you do this through HTTPS. This is really important. If we didn't have encrypted payloads, then we'd have to send our passwords and banking information and health information and everything through some other means. So now further request types like put and delete and so forth, they deal with file management, and they're not so common for the sort of work that we're doing. Really, for the most part, you're dealing with GET requests and the occasional POST request. If you have to send up some credentials, maybe to get an API key or token. So now, one way that this has all been abstracted is through the requests library. And so this will create a request object, which you can then, get data from. You can post data as well. But then once you get that, you can read it and store it in a variable. So what you get, you get a response, and the response has a response header, and itself has a response payload. So the header has useful information for the browser, maybe what sort of encoding it is, how much data is going to come down, the whether it's zipped up data or not. Often data comes down actually in a zipped format because it's smaller and just is unzipped on the fly. Also in the response header sometimes are things that are useful for you. So you will see in the response header to certain API queries, it'll come back and say, here's how many queries you have left in the next 15 minutes or on your account or something like that. So you can see those in the response header if you care to look there and show that in the book. The response payload is really what we normally want. That's the page. So if you're looking for a web page, the response payload is that all that HTML as text or all of the JSON data that you request. If you're working with a server where you're repeatedly sending data out and you're getting data back and sending it out and back, and you probably will make use of things like the same user agent every time, or maybe a cookie that says that you've already done some sort of credential access or something. In which case, you might want to create a session rather than just do a single request get. And so later on, now as we move on, I'm going to be using Reddit data where I want to set some settings like user agent strings just once, and then repeatedly use that data in order to request some data from the web. So that way I would set a session and put the headers in the session, and so each time we request, it'll include that information. Now, before we go on to do that, I did want to just briefly mention user agents and some things about Reddit data as a norm. So Reddit has some norms for programs collecting data, some rules, they might say. There they are right here. Just to summarize, first, be patient. No more than one request per second. So for that reason, we put a time.sleep and then the number 1 inside, because time.sleep accepts the default parameters are in seconds. So now, some data is only available through authentication, and so that's just how it is. Maybe it's data about a user or a user's personal account, and if you don't have the right credentials, you're not going to get that data. Now, you should identify yourself in a user agent string. That is not, strictly speaking, a form of credentialing. You could make it up. You could copy mine. I'd rather if you didn't, if I'm honest. But I mean, that might happen. The thing is that there is no extra guarantee that it's me. But the reason why we do this is because a Reddit server can and will traffic shape. A lot of people who are just trying out some data on Reddit, they'll just use a whole bunch of GET requests, and they'll all have it Python 2.7.1 or whatever is the version that is being sent up. And so then Reddit perceives all of them as kind of being the same agent, and thus it's not just us and our time.sleep one that we've got to worry about, but everybody else's as well, and that can potentially cause trouble. Or Reddit can simply refuse to send back the data. So we really should have a way to uniquely identify ourselves, and if they give a best practice for that, maybe that means they have a tester or a parser. Maybe that means they have a parser that can like determine these things, and it works for them. So it'd be nice to abide by that. So now those user agent strings can be set in Python as part of the headers. So we update the headers. In this case, is a dictionary. So we update it with this feature right here, user agent, and like so forth. I don't think it's actually case sensitive on the web. Okay, so let's go have a look at that in Jupyter. So here's a web request. Here's one to Google. You'll notice that what it did is it redirected us to consent.google because we're getting something from the web, and that's the way it does it. It says, do you want to let us collect your data, and so forth. So request headers.keys. I didn't paste the whole header. There's the request headers, like all this, but you can see some keys here: content type, vary, cache control, whatever. I don't really make use of much of this data, but sometimes it can be useful. Now you notice here's the request.content. So we got with the URL and our parameters, and here's the content. And so it's just stuff like this, and it just says here's the consent screen or whatever. Now I'm not going to go through the whole paging example, but we're going to dip into it just for a sec. Here, let's show requests again. We've also imported JSON and pandas. And here's the session. So up above, you'll notice I said request.get, got the URL, some parameters. And down here I created a session. And then when I did that, request.session, updated the headers, and now it's s.get. So s is the session rather than a requests object. So we go s.get this, and it's going to remember the user agent if we use s.get again for something else. So I'll do that, and we can see that there are some keys there. This looks good. And what we did is we got one listing, I guess, of 25, probably 25, 250 rows. Oh, that's 250 columns. Wow, it's really wide data. And indeed 25 entries that we received, 25 different rows of Reddit posts. And so that all just kind of came down this way by getting the session header, updating that, getting the stuff from Reddit, loading it as JSON, and then we can work on it there. And at this point, kind of getting familiar with the idea that a lot of this will come down as JSON or as XML. Okay, so now we have one request, so that's the first 25 stories. Great. But we really want a distribution. Is any arbitrary 25 the right distribution? Probably not. So what we want to do is we want to iterate through Reddit's listings and collect a larger corpus. Now there's different ways to do that. And on Reddit, there's actually more involved and scalable ways using the archival database. But so I'm not using Reddit in this case because I think it's the best way to make use of Reddit, but rather because I think it illustrates a really useful point. So now, if you page through something, then you'll have some way to manage that paging. So the OMDB data, there's briefly mentioned in the book, or there was like a Muppet data set, and in exercises I commonly use some of those search results. Well, they just have a sequence, so you just ask for the first 10, and then the first 20, or the next 10, and then the next 10, and so forth and so forth. And then you can merge all of those search results together if you want to do some analysis on them. But now, another way to do it is by date. So Twitter does it this way, and if you're requesting data from Twitter, it'll give you so much data, and then you take the date from the last one and say, give me all the stuff before here, or vice versa, give it all me the stuff after here. Reddit does this as well, and we're going to have a look at that now in a second. So if we go over to Reddit and see here, this is okay. So first I'm going to go to just the website itself. Reddit.com, and this is the subreddit for cats and things like that. And okay, I always knew it would deliver for me. So anyway, here we are. She's having the time of her life. And all right, so whatever. Cute stuff, and it says limit 50. Limit 50 doesn't really make so much sense on the web address though. But now if I go to api.reddit.com, it's the same stuff, but it's in JSON. Now, you'll notice, actually, the default we had 25, but this time I put limit equals 50 up there, and instead we got 50 entries. Let's have a look at them. Here's all those entries there. I understand it's a bit small. Here, let's see if we can move that up. And there's all the data. Those are all the columns. Oh, the rain without a coat, so that was the puppy dog at the top, and so forth. So anyway, we got all this data. We also got an after parameter here. Look at this. Alrighty, so imagine this is not data we're using for collecting, but this is data that's used for paging. And so if I go over here and then remember the raincoat stuff. Now I'll say limit equals 50 and after equals this. So this is what Reddit wants us to do to page, is to insert that after, like so. So now this time it's still a listing, and we can unfold the data. It's got a different after right now, Y7A5 before, it's Y77. So these are actually, if you unfold them, Unix time representations, but that's for another day. Now if you go down here, are we going to see the raincoat? No. One of the reasons why I like winter, cuddles. I'm sure it's adorable as well. But the thing is, it's a different set of 50. And so you keep going through those afters, and you keep getting 50 and 50 more. Reddit will only It will stop at some point. I believe it's 1,000, and it might be 1,000 only through unauthenticated. But after 1,000, if you keep going through after, it's I don't know that it'll give you more data. It might just give you the most recent data again, or nothing. But you can explore that yourself by testing the limits of this paging. Okay, so we have that example here, and now down in Reddit we can see that paging. But before we do that, let's continue on just a little bit through here. You can also use an index. So Wikipedia pages have a revision ID, and you can use that when using the export command. So you can say all of them since a revision ID. It's not quite an index because it's not going to start from 1 and go 1, 2, 3, 4, 5, 6. But it is, so it's not a position, so it's not going to do that. But it is still indexical. You can still say, starting from here, move on and do that. And I have a cursor as well. Now, cursors are a little more complicated. They work with database objects, and sometimes it's in the background. You don't even notice that. But other times, you have a cursor object that you have to continually fetch data for. So it will move through the data, give you all that data, and then you say, give me the rest of the data, and it moves through the data some more and keeps doing that fetching task. And indeed, SQL is like that. So down the book and the code show an example with Reddit. There, each iteration of JSON returns the data and an after key. That's what I pointed out. So then the next URL should have an after value. Now, watch how I organize those here. So say after equals nothing first, and then results equals nothing. These are going to be the objects, result objects. So what we're not going to do is create one data frame and then keep adding to it. We're going to create a list of result objects, and then we're going to create each result object as its own data frame, and then concatenate them all. And so I'm only going to do a max count of 100, and it's only going to do 25 at a time by default. So it's going to do 4 iterations through that. And since here it's saying time.sleep2, I do believe it is 2 seconds. So I wanted to make sure I'm abiding by that. So it's going to be a bit of time. It's going to take about 10 seconds for this to run. And I'm running this live. So let's see how it works there. If you'll notice here, I'm not giving a heck of a lot of feedback inside. But, it's sorted. We've got 4 batches of data to be processed. If you're getting large amounts of data back, it is worth, printing some sort of counter along the way. A common way to do that is to, if you have a counter, so now this is like actually counting the Reddit stories, but if you have counter, and then counter equals 0, and then, you iterate the counter each time, counter plus equals 1, and then you might say if counter mod some number, 1,000, 100, equals 0, print. And you probably want to print something more involved, like, you are at, iteration number X. Now, what's this percent symbol up here? And what that is that's long division, or remainder division, integer division. So if you divide 101 by 100, and you get 1. And a remainder of 1. If you 103, you divide it by 100, you get a remainder of 3. So when do you get a remainder of 0? Well, at 100 you get a remainder of 0. At 200, and so forth. So thus every 100th time, this is a way of doing something every nth time, like print a counter, just give you some updates. But now I didn't have that there because this was a pretty mild example. But in your working code, you will appreciate having ways that update you, certainly on a slow task. So now these 4 batches of data are all in the results list. And so you'll see what I do here. PD JSON normalize I for I in results, ignore index equals true. So in this particular case, I'm taking each batch and normalizing it. Now you'll notice I can do that JSON normalize I because I didn't store all of the JSON. I stored something in particular. I stored results data children. Now, when we've explored Reddit data before, we learned that children there is the children is the name for the under the data object. And so here we have 0, 1, 2, 3, and so forth and so forth. Yeah, if we drill down to there, that gives us that list. That's our data frame. And we get n of those. Actually, we got 4 of those. So we're going to normalize all of them. And then that's going to be a list. And then we concatenate that list. Ignore index equals true. So we'll have a list of probably 100 odd items. Now you'll notice when we do that, and you might have seen this before if you've worked with the Reddit data, when it does JSON normalize, it might be data.ups, data.author, data.title. And so down here, I use this command, say remove prefix, if I.starts with. You might see other approaches. You might see other approaches to this, such as like if I :5 equals that or something, because this is the first 5 characters. The Python standard now is to recommend using starts with, ends with, and remove prefix for these sorts of tasks. And then we can just display some info, and this is info of the data frame. So it's going to work its way there. It was pretty quick. Indeed, 100 entries. Here's, and it's column 250, so it's 100 by 250. It's actually really wide data, even though actually most of that wide data is empty. Now the upvote score is, I believe, data.ups. So you'll notice here I didn't do this. Sometimes, if you have a column name and it doesn't have any spaces or anything in it, you can also refer to it this way. I don't always do that, but we've done it here. And so you can see I've done the ups, sort values, plot histogram. So we're going to have a little histogram of the upvote score for the most recent 100 on the subreddit. And so the most recent, there was, a handful that have an upvote score that's relatively high, but nothing's really huge and viral. I mean, this is not an exciting analysis, but it does show that we're already to the place where we can do analysis with this paged data. That allows us to stack a whole bunch of results together, put them in a data frame, and then we're there. Then we're able to manage and query that data. So now that was, in my opinion, it was useful. It was a useful exercise to do, and it's not uncommon to roll your own, so to speak, and create your own scripts, put your own files together. But sometimes it's just easier to use someone else's. Now, should you? A lot of people have asked that. Well, I mean, it's my work. Is it academically appropriate? Is it plagiarism? Well, it's probably not plagiarism. But remember, number one, you're responsible for your own research. And if you can be responsible for the utilization of another program, it's often reasonable to use it. We wouldn't say it's ideal, but it can be reasonable. And that's if you feel you can be responsible for it. So there are downloaders there on GitHub for things like Discord or Tumblr, YouTube, and Reddit. Often they will query the JSON and manage all that, maybe put it in a CSV or just spit the JSON right out for you, or do other ways in which they access these sites. There's also ways to export data from Telegram or WhatsApp and a lot of other apps where they might have an export button of some sort that comes down. It could come down as HTML, XML, CSV, or generally one of those file types we've seen already. Now, using other people's programs invites potential security risks and data leaks. So if do they also keep a copy of the data? Do they keep a copy of the queries that you use through that program? Do they phone home, for example, and say, hey, there's somebody using this program to do this? That's not necessarily a horrible thing, but it is one where it suggests that you're not entirely in control over what data you're collecting and where it's going. And if you're to be responsible for this program, you should probably be responsible for the data that's created from it and where it goes. So indeed, they might store IP addresses and other things on an intermediary site. This is often a potential concern where we have things like, in more qualitative research, an interview transcript. And sending that interview transcript off to an automated service, or sending an audio file off to an automated service to be transcribed, well, you might really want to know what their privacy policies are, or what's their data retention plan. Do they delete this data when it's no longer in use, or do they say this data is going to help us build a database of how people talk, which you may not have asked for or wanted to be a part of. So you can be, in one sense, you can be trusting with good platform signals. Do these applications, are they open source? Are they starred on GitHub? Do lots of people say like, hey, this is really great, I want to watch this, or fork it? Is it forked a lot? So you can get some sense that whether these things are trusted, used by other people, written by university researchers, for example, but you should never be too trusting. I mean, really, it's important. Remote code execution is a very real risk, both in Jupyter Lab and via the cloud. I don't want to scare you off of other programs, but I think that oftentimes a lot of people will reach too far in explaining the problems with these things, and then when people use them and go, actually, it turns out the data's okay, they kind of lean into it, but in a casual or low key way. We we want to be able to use these programs in a more confident and be specific way, and for that, just to be able to cross check that they are doing what they say they are doing in the best ways you can establish that. That's a good practice. So now there's also browser simulators as well. Sometimes the best way to collect web data is to pretend to be a human. I mean, get the program to pretend to be a human. And, this can take varying levels of complexity. If you notice in the book, when we did a GET request to Google, it came back to, here's the consent statement, and do you agree or disagree or whatever. That's not what we wanted. So a request wasn't really doing what we needed then. We needed to, click on a consent statement. So is there a way we can do that? Sure is. So one way is mechanical soup. This is a Python package that's inspired by Perl's widely used mechanized library. Okay, parse all the URLs on this page, and we'll go down each URL one after the other. Mechanical soup can do similar things, except in Python. And it's not just can you navigate all the URLs, but can you click here to agree or post some data? And indeed, Mechanical Soup can do that as well. However, some web pages are particularly tricky, and Mechanical Soup is just not going to do it. But you can see it on the web. You can see it there. You can see your Gmail account or your Facebook profile page or whatever. And so surely it can come down as data and you can see it. So can you collect it then? Well, rather than using Python to do simple web tasks like requests or to kind of be a browser like Mechanical Soup, we can also use it to just control our browsers. And so Selenium is a package for that. And Selenium, it's used in Python, but it's not just Python specific. There's Selenium implementations elsewhere. Now, from my experience, Mechanical Soup is often a really useful middle ground and can do a lot of great tasks online. But few tasks seem to escape Selenium for the committed and otherwise frustrated. And by that, I mean that from experience, from hearing of students who I have a goal to collect this data, and they try scraping it or APIs and it doesn't work, but the data is very much there. And I don't want to say Selenium is the last resort, but I've never heard of someone who was wanted to use it and couldn't make use of it, only that it can be really tricky to do the interacting with the browser and get it right. So now some practical questions, getting out of that and back into the requests and how we can make use of it to actually get the data now that we've potentially fully scared us all about the risks. So, I've demonstrated to how to request data from Reddit, but we only received a little bit of data, 100 posts. Now, the site itself is vast. And as it happens, the push shift archive, even more vast still. That's an archive. It's stored on Google, and you can query it using a library. It's pretty complicated, but also has a lot of depth. Okay, but now, knowing that there's lots of data out there. Consider creating a small Reddit script that crawls the site. Start from one subreddit, maybe, whatever, and then pivot by users. So maybe get all of the users. Then for each of those users, where do they post? Okay, so now that you have that data, how do you structure it? Do we have one data frame per user? Do we link them together? Do we create a network graph of the same people that go to this post in the same subreddit? There's lots of different ways you can go with that. the reality is you can't continue scraping indefinitely. So then you'll have to be considered about, or you'll have to consider what is the scope of your data collection and how far should it extend in order to make a meaningful claim or help you make a meaningful claim. You might think of what's the stopping criteria. Maybe you look through all the posts to see if somebody mentions the environment or green technology or something, and then go through their posts and who posts on there and go through theirs, as long as they mention green technology, and otherwise you might stop. You might think, what distributions can we construct? Things like if we pivot, what are the distributions of the other places users go? We know that maybe the Lego subreddit is for people who build Lego, but is it also for people who do engineering, or is it for people who do art? And looking where else they post, we might reveal an answer to that question. So in the next chapter, I introduce wrappers like PRA, the Python Reddit API wrapper. And in some ways, PRA or other sorts of wrappers can make this task easier. But they also sometimes constrain our approach and make us think more like the wrapper and the way the wrapper structures the data, then think abductively beyond the interface, what is there and what we think we can learn from what's there. So if you can navigate the Reddit parameters using the URL, like the afters and so forth, you can still accomplish an awful lot. So now consider the data that gets returned. Just as a final thought, when do you store it in a data frame? When do you save it directly to disk? Right away? What if the program hangs? Do you have to start again? Do you have a way of saving your state, or maybe saving the most recent after, or maybe reading from the data on disk says, if there's no data in this folder, we just start from now. But if there is data, we'll start from that after. These are all skills that help you build out from just a simple, let's do a pull, to something that's more enduring that can say, allow us to do a pull of a very large amount of data, and thus hopefully make the kinds of comparisons that you want to make. At some point, we might run up against some limits, and some of those limits are because we're just asking for things unauthenticated. But if we let the site know who we are and that we have some sort of credentials, that we can do something more. So we're going to look at that in the next chapter on APIs and data access. But for now, thank you for listening.